For the e-tron project, we had to incorporate every single bit of knowledge and expertise that we as a department had in both the fields of aerodynamics and aeroacoustics. My name is Moni Islam, and I'm the head of aerodynamics and aeroacoustics development at Audi.
In terms of aeroacoustics, an e-tron has similar problems than a conventional cars, and we have learned to solve these problems over many years. My name is Gerhard Wickern. I'm doing aerodynamics at Audi for the e-tron project.
Aerodynamics plays a key role in the case of electric vehicles, the driving distance of the vehicles. And aeroacoustics is very important because it's essential for the noise level inside the car.
The Audi wind tunnel, when it was starting, it was an industrial wind tunnel with ground simulation, so moving around underneath the car, before only used in Formula One. Or because our wind tunnel is so silent, we are able to develop more silent cars.
The sound of silence is actually a really important concept for us in aeroacoustics development for the e-tron because it doesn't have a combustion engine. It's extremely quiet, so that means that all other noise sources will be all the more prominent. So we set ourselves the target of making a really, really quiet vehicle for the e-tron.
The e-tron was a very interesting project for an aerodynamicist. It was a rare chance to start with a white paper. And you get a lot of things as an aerodynamicist you always dream of.
I think one of the unique things about the e-tron is that it has this very sporty, very coupe-like silhouette, which is quite uncharacteristic of an SUV. One of the very fundamental reasons it has this shape is that the aerodynamics require it. Since the e-tron is a fully battery electric vehicle, it gives us as aerodynamicists quite a number of possibilities that we can work with to generate an aerodynamic optimum. First off is the fact that we have a closed and a flat underbody, which is the dream of every aerodynamicist.
On an electric car, there's a large area which is smooth and flush anyway because it's the undershield of the battery. And for the rest, so under the axles, we have designed nice covers which are equally flush to the battery underside.
We have another feature like the active inlet shutters, which allow us to restrict the flow of cooling air to configurations only where it's needed.
An electric car needs much less cooling than a conventional car, so we have a cooling shutter which closes.
We have the inlet ducts at the front side of the vehicle, which allow us to channel air in a very efficient way from the front to the side of the vehicle. We have included acoustic damping glass, which basically filters out the important frequencies of wind noise. We took the best of everything that we had in our toolbox and we developed it into this vehicle. And the result is what you see now, or actually better, what you hear now. It's an extremely quiet vehicle, and it's one of the quietest vehicles in its class.